All right. I'm going to just start from the beginning. We're going to do a Netflix story time. Are you guys ready for this? Because this is pretty dang good. This is pretty dang funny. So obviously somebody caught me on one of my things right here. This is the last of the statically referred to keys. This is a change in which we went from doing something that looked like this, where we did a bracket access versus a dot access. Bracket access and dot access go through different internal things. At least at one point they did. I'm not sure if this is even true anymore with JavaScript. The problem about JavaScript, obviously, is that you don't know why things are fast and why things are slow, but you can kind of reason in your head why it is versus why it isn't slow. Let me give you a quick reason why you could imagine that is slow versus not slow, okay? And I'll tell you the story about Netflix here in 1 second. Okay, so you have some sort of object which has many properties on it, right? Underneath the hood, how are those properties represented in memory? I don't know. Maybe a tree of some sort, right? I have no idea, right? Maybe some sort of Fibonacci tree. I don't know. Fibonacci, these nuts, right? And so if you go like this, .foo, well, the bytecode can say, hey, give me property foo. And this can be like a calculated thing that's like, okay, I'm going to get this property. And when I get done getting this property is, item number fo if the thing is of this certain shape, right? If it's of shape X, which if you keep all your objects having the same shape and then you do dot accessing, you could imagine that specific optimizations could theoretically be made. Okay. Fantastic. Now, what happens when you do a bracket access with the variable? What is the value of the variable? I don't know. Do you know? No, you don't. So we're going to have to go down. We're going to have to string compare and do whatever it's doing to get down to the correct location and go, okay, there we go. We got the right thing. Now that we got the right thing, let's put it into here. And so this massive speed improvement came from me removing references that were required in by internal parent point or whatever and actually hard coding them into the code. Now, somebody got really clever with this because the general idea is that we don't want you, the JavaScript developer, even like realizing you can access the cache and manipulate the cache. Me personally, I would have put a little note there that said, hey, you access the cache, you dumb, okay? This is your fault. You touch our cache, you ruin your life. Not me, not my problem, right? Well, we didn't go with that. Instead, we had these really dumb little things that we put on here. I forgot the name of this character. Funny story. This is a UTF-8 character. This is not an ASCII character. So you want to guess what happened when we put this on television devices? Memory went up. Why? Why did memory go up? Well, there's this man named some coding guy, Guy Serino, that used to work at Netflix, and he made this optimization where if the source string coming down from the interwebs would be stored as UTF-8 instead of UTF-16 in these specific instances where there is no UTF, like larger than single byte characters within the source code. So that way we could actually cut down how much it takes to store JavaScript code. Because if you don't know, JavaScript engines often store things in UTF-16 versus UTF-8. Fun fact. I don't know the reason why. I'm sure there's a great reason why. I don't know the reason why. The end. Okay, so now that we got that out of the way, when we did this, our entire 4 megabyte file, or however much JavaScript we sent down, went from 4 to 8 megabytes. And there was literally just like just a straight up upwards curve of how much memory was used because we used a non-ASCII character. This was later changed, I believe, to $__. Okay, but there you go. That's the little Netflix story. Fun little thing right there. I don't know why, the things you do at a FANG company are incredible. Okay, I really loved my time at Netflix and building Falcor, and I really hated my time at Netflix building Falcor. But that specific one was such a silly discovery where I'm just going around being like, all right, we need to improve Falcor speed. You know what really bothers me? Using references to access objects. And I think it could very well be, I think it could be slow. Did a little bit of testing, boom, massively slow. Okay, so boom, we're gonna do that. Next, we use a lot more memory. Why would we use a lot more memory? Well, again, geez, look at that. It was as simple as don't use non-UTF-8 or non-ASCII based characters, you dummy. And boom, it was absolutely fantastic. Do I miss Netflix? No, not at all. Favorite project at Netflix? Ooh, probably Reggie. Any of the real-time gaming stuff was a lot of fun. Anyways, there you go. There's your fun little story about Netflix engineering. By the way, the day that I quit, the day that I knew that I hated Falcor, I was kind of building up and kind of building some momentum and all that. And I still remembered I believe it was December 27th. And I got a phone call in the middle, like post Christmas, like right a day. It could have been December 26th. I got a phone call asking for more features. and talking about more stuff. And it's just like all I wanted was a little bit of Christmas time. And man, I'm talking about data fetching during Christmas. Oh man, like that's how I knew. That's how I knew for a fact I was done. And that's really the day I quit working on Falcor. Yeah, there you go. The name is the F's for Falcor, Agen.